from the solution to our differential equation, we can alter the equation around and solve for different variables in order to look at different cases that the application can be used for. I'm going to pull this over here so you can see it better. Basically, just what is on the screen. I have a couple different pages. Let me see if I can. Okay. There's a couple different pages for each different case. Specifically, the first 3 pages are going to be based off this process. The 4th and 5th page are going to be based off the second model, which I don't have a process in order to simulate it, but I still think it'd be interesting to look at calculations from what we should expect from the process. Case 1 is you know your initial water level from the sensor. You input the duration you want to drain the fluid for, and then we can calculate from the solution to our differential equation. We can calculate what we should expect numerically based off this process, and then we can run it. Our calculation will give us a value, and then we can run it. I can time it, open the drain valve for that given amount of time. I'll try and time it, and then from the sensor we can get the actual final water level after I've drained it for that amount of time. Case 2, which would be to calculate the time it would take to completely drain the tank. Again, you know your initial water level, and you want to solve for how long it takes for that initial water level to reach 0, altering the equation around to solve for final water level z equals 0. The third case is you give it a final water level that you want it to reach. So in our case, we're going to be starting with the initial water level at 6 inches. Let's say you only want to drain your fluid tank to 3 inches. What time duration should we expect in order to drain it to reach the final water level? Again, we'll have a timer on here, and then I'll open it and I'll open it for that amount of time, and then we'll compare the computed versus the actual value. I'm going to start with case 1. I'll try and I have a graph which we can look at first before we do it in order to get an understanding of what we should expect. And this graph is generated already with the parameters from this process. So our drain valve diameter is 3/4 of an inch, so 0.75. The diameter of our tank is 10.5 inches. And then our initial water level height, which should be pretty close to 6 inches off of our sensor is reading about 5.8 inches. So our graph will be shifted because this graph starts at 6. So our graph will be shifted a little bit because it's not exactly at 6 inches. But if we input, let's say we input 10 seconds, we want to drain the fluid for 10 seconds, what should we expect our final water level to be? 10 seconds should be about 3 inches from our graph. Let's run the calculation. So our initial water level, 5.75 from the sensor. I'm going to input 10 seconds into duration you want to drain the fluid, and then I'm going to calculate. Down here, we have the calculated final water level is about 2.3 inches is what we should expect. Which, based off the graph was 3 inches, but it is shifted a little bit, so there is some variation to it. And now I will try and open the drain valve for 10 seconds, and we will look at the final water level, which that sensor will be reading. Should be displayed down there. So I tried, I counted 10 seconds. I don't know how accurate my count was, but here we have our calculated 2.3, and then actual final water level from the sensor is 2.7 inches. So pretty close to what we calculated from the solution to a differential equation. Now I'll try and do case 2, which is to see how long it would take to completely drain this tank. I'll reset it and we'll do case 2.